Let's hope this time it catches. Hey!
Hey! Alright, starting.
Content.
You're live.
The internet can totally see you now.
You see me right now? Hey!
Hey!
Look,
Hey!
there we are.
You need a website. Why not do it yourself?
Yeah.
No.
With Wix, you can create your own professional website.
That one we might want to mute.
Yeah, close that one. Okay. Alright. Hi, I'm Anthony, and this is...
I'm Joe Mike.
Okay. This is going to be really informal, and we're actually doing this live stream while my kids are trying to nap, so I might be in and out. But I called my buddy Joe over. I've referenced him a lot in my videos. He's got a YouTube channel, 3D printing stuff. It's really good. Check out the link in the description below, or however you're looking at this. If you're on a TV, I don't know what to tell you. But extrusion issues with the printer I've been using, and that's a Hictop Prusa i3. It's actually on loan to me from Joe. But I've gone through a lot of things, and I'm just going to kind of let him walk me through how I might troubleshoot this issue, but also walk you through a way to potentially solve the problem as well. Basically, it's been stopping mid-print. I might get 10, 15, 20% through a print, depending on how much volume it's trying to print, and then it just stops. So, yeah.
So you and I have been talking about this for the last, 4 or 5, maybe even a week, since this has been going on. So basically, we've troubleshot a couple different possible things. The actual printer itself runs a Bowden setup, so we've tried moving the actual physical extruder location to kind of give that Bowden less resistance. We've done PID tuning on the hot end and a bunch of other stuff that, ultimately didn't work. So we started looking closer at kind of the behavior of things, and we noticed it kind of stops the same location around the same time. So one thing that I was telling him about, and I have yet to do a video on, which I should, but there are videos out there, is adjusting what's called the stepper motor reference voltage. And we're going to do that today on this printer. And basically all it is a way to limit each stepper motor how much current it can draw. So if it draws too much, it overheats, it trips a temperature limit sensor, and then you have to power it down, wait for it to cool, start it back up again. If it's underpowered, then you start skipping steps, which if you're on the Y or the Z, I always get those mixed up, the Y and the X axis, then you get to see, those print shifts. And that's what happens when steps are skipped. So the same thing happens on the extruder side as well, and eventually it just overheats and it just stops. So we're going to go ahead and try to dial the Hictop in and see if that fixes your issue.
That sounds good.
So yeah, let's go ahead and break down what we need here. Can we switch this?
Lower left. Yeah.
Hey. Okay, so this is the Hictop that this was actually my first printer. I think I told you that. So it's kind of my child of sorts, and I've done all kinds of weird things to it.
And
but
I'm clamping things onto it now.
Clamping things onto it. Your woodwork influence is definitely now apparent on it.
Yeah. Nobody can see what we're looking at.
No.
But if you follow me on Instagram, you've seen it.
Well, we could probably angle this real quick so you can see more. Yeah, I'm going to trick this back real quick. So you can see he's got a piece of wood here, and he's clamped the extruder motor at the top of here, and then the Bowden tube's running down. The original setup that I had was this guy was clamped on the back here, and then the tube came over the top, kind of like the TiVo setup.
Yeah, and basically what I was trying to do is see if friction was maybe causing the problem. So making that a straighter shot from the extruder down to the hot end, it did, I think, help improve the flow, The quality seems to be much better, but I'm still having the issue with it shutting down. So I think I will go ahead and relocate the extruder, but I wanted to test it out first before I started cutting tubes.
Yeah, and one thing about using a Bowden setup is that there is definitely added friction there in the extruder line. It has its benefits and it has its downfalls. That's one of its downfalls, is added resistance. But at the end of the day, there's ways that you can take care of that. I'm going to switch this back real quick. Have we checked the almighty chat here? Anything?
No, just me. We can say something back to me.
Huh. I can get on my phone.
There's one person watching.
That's me.
That's you?
That's you.
Oh, wow. That's us. We're watching ourselves.
We are watching ourselves. That's okay. Let's go back to OBS. Okay, so basically, Mr. Anthony, what we're going to do... Do you need to go take care of Camille?
So my daughter's making sounds. I'll be right back.
And while Anthony is taking care of that, I'm just going to go through some of the things that you'll need to adjust your reference voltage and kind of where all that's located.
She's just playing up
Just
there.
playing? Yeah. So are we. Except with electricity.
So you were just talking about how you absolutely want to use steel tools.
Absolutely.
On this, right?
You're going to be digging in around all kinds of like little itty bitty components. So the more metal you can just jam in there willy-nilly, the better off you are.
So it's got the printer has a BL Touch, which is a bed leveling sensor on it, and those wires came unplugged on me the other day when I was moving the extruder around, and it took a good 10-15 minutes to figure out where they went, and I did plug them in the wrong spot at one point, so I'm glad nothing was fried. But yeah, make sure that you use the proper tools.
Yeah, and this is basically, this is a ceramic flathead, so it's non-conductive. It's perfect for doing what we're doing. You can get these at electronics stores. You can get them off Amazon for a couple bucks. A lot of kits come with these. Both of my Folgertech kits came with a ceramic screwdriver to adjust reference voltage. So I've got a couple of them laying around. Definitely don't go adjusting these trim pots with a metal screwdriver because there's so many small, delicate resistors and other tiny components on this thing that if you were to slip with voltage applied on this board, which in order to adjust this there has to be, you're going to not have a great day.
Yeah, and that's kind of the first part of the live stream. Joe's part of a live stream every Friday night with a lot of the YouTubers that are in the 3D printing community, and they talked at a pretty good length about safety last night. I think that was kind of unplanned.
It was semi-planned. We got a little bit more deep into it than I think we initially thought we would. But
yeah, but the thought about, at least being careful, but if you have a young child and they want a 3D printer, trying to be even more careful when you select that printer. You want to make sure that it's something they're going to be able to work on and work around without running the risk of shocking themselves. As you can see here, we have an open board. There aren't really that many exposed wires, but still, I wouldn't go laying my hand on it.
Yeah, and with this particular test / adjustment that we're going to be doing, we're actually not going to be applying the main voltage. So you've got a main power supply that really pumps your amps and that provides the current for the hot end, the motors, and all that stuff. All we are caring about is a reference voltage, and we can get that by just plugging in the USB. So the board is powered by the USB supply, the bus supply, which at max is about 2.4 amps, and it's not going to be drawing anywhere close to that. So as far as a shock hazard for us, it's very minimal, but again, with a metal tool, you could still short some stuff out.
Yeah, at the very least, screw your printer up.
Yeah, you could fry the board, and then you're in the market for a new board, and back to square one. But yeah, so let's go ahead and kind of boil down what we're looking at here. A lot of people are going to find that you see a lot of different boards out there. So you see the ramps board, you see MKS boards, you see just about every variation and combination of the Arduino ramps system. So this is no exception. This is more or less kind of, I don't know, not proprietary, but Hictop uses this board more than anybody else. And this is really the first time I've seen this board. And what it is, it's everything built in, so it's got the Arduino built in, but it also has all the ramp stuff built in, which, like the MKS stuff, that's all the same. Where the difference comes in with this particular board is the drivers are built in. And you don't see that very often. In fact, you really only see built-in drivers on like Rambo boards and smoothie boards, stuff like that. So to have the drivers built in is just more of a rare thing for this style and type of board. But nonetheless, we can still adjust the drivers. So what we're going to be looking at here, you can see that each plug-in, I can't tell if I'm blocking stuff here, about popped over my T. So everywhere that these motors plug in, there is a chipset that goes along with them, and these are all the driver components that you would normally find on the little driver chips that you push into the headers on other boards. So you find that all the stuff for it is also lined up right next to the chipset. So you want to basically say that this entire section right here is the built-in driver. To adjust the reference voltage on this compared to some of the other ones out there, it's the same thing. You basically have to use the trim pot, which also is your positive test point, and then use a ground point to see what voltage you're running on that. The higher the voltage, the hotter the motor will run, the more torque it'll have available. The lower the voltage, the cooler it will run, but again, it might start skipping steps. Tom actually did a really cool video a while back about manually tuning these. So if you wanted to, you could sit there and twist the pot and do some testing and test your motor's hotness, see the temperature of that, and see if it was skipping steps or if it was getting too hot, etc. So it's not really a perfect science. You just kind of have to adjust until you're not experiencing any issues.
Yeah.
So what we're going to do first off is see kind of where we're standing on voltage right now. So what we're actually running is the extruder driver, which here's the cable for that, and you can see that's in position 4 down here.
From the top?
Yeah. And this is a bloody mess here. So I'm going to just use common...
I will say that's not my fault.
That's totally my fault. This is the first printer I ever built. It's my Hictop Prusa.
Do you want me to try and find a flashlight or put this headlamp on it? Would that be helpful?
I don't know. I think it's pretty clear. That might add some glare.
Yeah, we'll just put it right there.
Yeah, perfect.
That way we hide what we're doing.
Okay. So I've got my negative lead from my tester, which I've got set on DC voltage. I'm just going to put this onto a common ground source that I know is common ground. So the main input, even though we're not pumping any power into it, it still goes through the common ground of the board.
And those are the wires coming in from the power supply.
Yeah, and on traditional steppers, there's actually a pin that you can use as your ground source instead of using this, because you never know what's between here and there.
Right.
So there could be some added resistance there that you just don't know about. So, and then I'm actually going to use the pot itself. I'm going to roll over here, and again, we got to be very careful because this is metal, and my hand's in the way.
That's all right.
So we just want to kind of set the positive lead on.
And that's on the trim pot, right?
It's directly on the trim pot. And you can see we've got a reference voltage of 0.93 on our meter here. So I'm just going to remove my leads there. Take my handy dandy ceramic screwdriver. I'll find that pot And I'm not sure what direction is up and down on this one. So we're going to have to just test it a little bit. I'm going to turn it counterclockwise because intuitively counterclockwise is usually down.
Mm-hmm.
So who knows where we're at now. But I'm going to turn it counterclockwise just a smidge. And then retest and see if we went up or down in voltage. That'll at least let us know what direction we're going. Okay, so we went up.
Mm-hmm.
So it's counterintuitive, which means that we're looking at it upside down. So now I know I need to go down. Clockwise is down. That's where we were. And let's see where we're sitting nowsies. Okay, 0.75. I think I'm comfortable with taking that down, just given the fact that we're overheating. Well, I want to find it closer to 0.71. I know that's splitting hairs, but this is all about splitting hairs. You really can't split hairs enough on this. 0.68.
So back counter.
Yeah, just ever so slightly. See, just jumps on you. We're on 0.75.
So based on what we just talked about, if you're watching this, your printer it will probably be different than this, but it will be a similar method to testing the voltage, I would imagine.
So that's 0.698, which is close to 0.7, which I am going to be comfortable with.
Give it a shot.
Yeah, so with adjusting, we want to go ahead and do some test prints. About how far up on the print does it usually go out on you?
I mean, it was like an hour into it.
Okay, so more time than actual print location.
Yeah, the extruder had to be running for,
about an hour.
Uh-huh.
Okay, so past that, what we do is we go ahead and we run a test print that we know is longer than an hour. And then we take a look, we see if it completed the print or if it crapped out again. If it crapped out again, then we'll trim it back. Actually, if when it craps out, it'd be a good idea to kind of get a feel on here, on the extruder itself, to see if it's super duper hot. If it's not super duper hot, then it might be another issue. But at least now we're addressing this one.
Mm-hmm. So. Yeah, and just to kind of clarify, sorry if it's loud, I'm sure it is. I had done some atomic pulls on the nozzle, so I was confident that the nozzle was clean. I had tested the height or the distance from of the nozzle from the bed, so I know that I wasn't too close to anything, which can cause things to have issues. The tension on the spring in the extruder was fine. The little gear inside the extruder, I tried to go through the process of elimination and knock all these things out, and that's why I called Joe, because I did everything that I knew to do. So now that I know this, I have a multimeter. I could probably test it, and if I get a little ceramic screwdriver, I could probably.
I'll leave you this one because I've got a couple.
Cool.
So, yeah, so if you're having extruder issues, like he said, make sure you have a clean and clear filament path all the way from the entry into the extruder body through to the nozzle. Make sure that you're not too close to the bed. That seems to be a problem anymore nowadays. People are trying to get good adhesion, so they squish too much, which actually ends up. A couple of symptoms of being too close to the bed or having a partial blockage or a major blockage is you're going to get grinding inside of your extruder body with that hobbed gear. So if you're seeing grinding, that's usually the issue. You've got some kind of blockage or uber resistance in your filament path. But if it just stops on you and you're not seeing grinding, like Anthony is not seeing grinding on this, so you probably have a different issue altogether, which could be overheating, under power, etc. So we just adjust it that way.
Cool. Well, I will do some test prints probably as soon as we wrap this up, and I'm not going to make you guys watch an hour of printing to see if it freaks out on me again.
You could do a time lapse.
Yeah, I could do a time lapse. If it's successful, I'll be giddy, and I'll share the time lapse all over the social media. But
Quick Trip plug.
Yeah, there you go. Quick Trip, if you're not a sponsor of this channel or Joe's channel, we would sure appreciate it. We would take a soda for every video, or a taquito.
They could pay me in taquitos.
Yeah, I'm a fan of their taquitos. But anyway, if you have any further questions for me or Joe, feel free to leave a comment or check out Joe's channel again. It's linked in the description. Joe and I are both in Kansas City. Joe always wears Kansas City gear, and regardless of what I'm doing, I'll probably always have this apron on. It's kind of my thing now.
Looks good on you, man.
Yeah, but look for more collaboration videos. We might tackle an enclosure for a printer at some point. Joe just moved into a new makerspace, so I might help him with a little bit of stuff down there.
Need to hang some shelves and stuff, and yeah, I need your skill set, not mine.
Yeah, we can do that. But anyway, we're both on Patreon. If you guys like what we do and you want to support us, I can put Joe's link in along with mine. Mine's already in the description. $1 or $2 a month really does go a long way. It helps support our habit, our hobby, and it helps us to create better content and more frequent content for you guys. But that's about it. Like, comment, subscribe. Again, check out Joe's channel, and see you later.
Sounds good to me.
Okay.
Bye, everybody.
Stop.